Okay, folks, for the second video, we're going to have to jump right to the acceleration. I don't want to take up too much more time to do another speed problem. So we're going to look at the first acceleration problem on the back side of your paper. This is question number 5 about Quagmire and his car. So the question says, Quagmire's car was at a red light. When the light changed to green, he stepped on the gas and the car accelerated to 15 meters per second. So we have that information. We know we're going to have to go 15 meters per second. And we see it took 3 seconds to reach that speed. Now we also know something that isn't really explicitly said, but we know that he was at a red light. He was sitting at a red light to start with. So we know his beginning speed should be 0. So let's take that given information and list everything that's been given to us in this problem. And then we're going to solve, by the way, at the end for our acceleration. So let's go over here to our guess steps. Starting with given. We know, I'm going to put this down as VI. I just mentioned this. VI, the initial velocity or initial speed, is 0 meters per second. It was not moving at all. We also know his VF, his final speed at the end of this little sequence. He was going 15 meters per second at that point. And we also know the time it took. The time was 3 seconds it took to get up to that speed. So our initial speed was 0 meters per second. Our final speed was 15 meters per second. And the time it took to get from 0 to 15 was 3 seconds. The unknown is acceleration, so I'm just going to put A equals question mark. That's our unknown in this problem, is acceleration. Equation for acceleration. The equation is acceleration equals, and it's another fraction, it's another ratio, VF minus VI, that goes on top. That's again my final velocity or final speed minus my beginning speed. Now these don't get the bars over them because they're not averages anymore. This time we're just looking at what we call instantaneous velocity. What was it at that instant? So what was it at the end? What was it at the beginning? And then divide that by the amount of time that it took. So we go down to the next step where it says substitute. We're going to substitute in the information that we know. We don't know acceleration yet, so we're going to leave that A equals. The next part here is VF minus VI on the top part. For the numerator, VF was 15 meters per second minus 0 meters per second divided by the time was 3 seconds. Alright, what happened? Let's try that again. There we go. 3 seconds for the time. If we solve that, A equals 15. Wow, that got ugly. 15 for the numerator. 15 minus 0 is just 15. So that's 15 on top. Divided by 3 on the bottom. Equals 15 divided by 3 is 5. And this is the 15's, the numerator part. 15 minus 0 was, the units were meters per second. So that's meters per second per second. Meters per second per second. Or the better way to write that, the easier way to write that, is 5 meters per second squared. So acceleration in this case was 5 meters per second squared. That means for every second that he drove, he was getting 5 meters per second faster for those 3 seconds that he was driving.